Okay, we're going to take a look at conjecture number 6 on your theorem sheet, your blue sheet. So I'm going to go ahead and read it, and we're going to try to figure out how we can complete it, what would be the appropriate thing to put in there, and then obviously set up a proof. If two lines intersect to form congruent adjacent angles, then the lines are... Now, we haven't talked a lot about relationships between lines. We've talked about more relationships with angles. So I'm guessing that you have a thought there. And then I'm guessing that you already have something on your paper. But let's go ahead and take a look so we can start to see why we might be saying that. So we've got setup as two lines intersect to form congruent adjacent angles. So I'm just going to draw a picture, obviously, of two lines. And I'm going to label those two lines L and M, just because I need to put labels on there. And then they intersect to form two congruent adjacent angles. So adjacent are next to each other, so I'm just picking out a pair of adjacent angles. I could label any ones I want there. And what I know is that those two angles are congruent to each other. Now, if we start to picture, and I know in class I did this today, I said, okay, well, what if the lines weren't perpendicular to each other? So what if we had a picture that looked like this? Then the lines wouldn't be perpendicular and the angles are not congruent to each other. But the fact that the angles are congruent to each other seems to lead us to believe, oh, then they have to be 90 degrees because they have to add up to 180. And all of this is good thinking. If you're thinking this and following my train of thought, a lot of you are already doing this in your head. You're saying, well, then they have to add up to 180, which means they both have to be 90 if they're congruent to each other, and 90 degrees makes perpendicular lines. So I'm agreeing with that conclusion that they're going to have to be perpendicular to each other. So let's go ahead and see if we can set up a proof to say this. Remember, the hypothesis of our sentence turns into the given information. So I'm going to grab this and I'm going to turn it into, that's after the if, and I'm going to turn it into my given statement that it will use in my proof. So my given statement is going to be two congruent adjacent angles. Angle 1 is congruent to angle 2. And I suppose if I wanted to, I could state angle 1 and angle 2 are adjacent angles. I'm not going to because that's shown in the picture, and the picture is part of the given information, so I really don't need to state that. And then my proof is obviously the conclusion. So the lines are perpendicular is what my proof is going to be. That's after the then. So my proof is going to be that L is perpendicular to M. And I would encourage you to write this actually two places. Write it on your theorem sheet, because this is the summary of what this theorem is saying for us. And then to go ahead and write on another sheet of paper so we can set up a proof. As far as a name, we should be recognizing that this is the converse of theorem number 5 from your paper, which started with lines being perpendicular and ended with angles being congruent. That's going to be a hint for our proof process here. But let's go ahead and put a name for this one, and we're going to call it the, you can put the converse either at the beginning, converse of perpendicular adjacent angles theorem, or you can call it the perpendicular adjacent angles theorem converse. So I'm going to write converse of perpendicular adjacent angles theorem. I realize this isn't totally neat. Sorry guys, I'm working on my iPad, so hopefully you can make out what I'm saying. Converse of perpendicular adjacent angles theorem. In your textbook, that does have a number. That is theorem 2.11, which is the same one I gave you for the non-converse. Your book does put it all together, so theorem 2.11. Okay, let's go ahead and turn this into a proof. So again, you have two options. You can do the flowchart or the 2-column. I'm going to go ahead and stick with the 2-column for now, but feel free to set yours up in a way that makes sense to you. Okay, I'm putting statements on the left and reasons on the right, which I am abbreviating S for statements and R for reasons. And then I'm going to go ahead and grab my statement that I had for my given. And I just like to jot it down because I'm going to need it somewhere, so I don't know if it's going to get me anywhere at the beginning. Okay, so I know that angle 1 is congruent to angle 2. So that's my start of this proof. Okay, now, in order to get somewhere else, I'm going to have to be creative. And I can think about kind of like what I did in my head a minute ago to justify to myself that the lines are perpendicular. The other thing that I like to do, and you'll see this as a strategy that I will use from time to time, is I like to actually work from the end sometimes. So I'm going to temporarily move this up here, and I'm going to say, well, if I wanted to prove, because I know that I'm trying to prove that L is perpendicular to M, and I'm not going to number these right now, but I'm just going to do some thinking. If I want to prove that L is perpendicular to M, two lines are perpendicular, then what would I need to know in order to say that the two lines are perpendicular? Well, in order to use my definition of perpendicular lines, which is pretty much about all I have for perpendicular, in order to use my definition of perpendicular lines, I would need to know that angle 1 is a right angle and angle 2 is a right angle. But really, as long as I knew that one of them was a right angle. So I'm going to say I would really like it if I had this. And again, I can't just go making stuff up and saying I know that, but I can use that as a goal of if I got to here, then I could kind of read to myself this way. If angle 1 is a right angle, then this iPad is really not working. If angle 1 is a right angle, then L is perpendicular to M by definition of perpendicular lines. Okay, but of course then I need to figure out how to get a right angle. So then I say to myself, well, I would know that I have a right angle if the measure of angle 1 is equal to 90 degrees. Because if the measure of angle 1 equals 90 degrees, then it has to be a right angle by, and hopefully you're filling in the blank here, if this is true, let's make this my conclusion now. Then angle 1 is the right angle by, you got it, definition of right angle. So now I need to figure out, okay, how do I get that angle 1 is 90 degrees? And here's where it's going to be tough, because you're going to want to say that it's 90 degrees because of the fact that the lines are perpendicular. But I'm going to remind you that you don't know the lines are perpendicular yet. The lines being perpendicular is what we're trying to prove, and therefore we can't use that as a reasoning. So we're going to have to somehow magically come up with the fact that angle 1 is 90 degrees. I do know that 90 degrees is 1/2 of 180 degrees. So I'm sort of going to go back to my drawing board at this point. I'm going to say, well, don't have much to start with here. I can't make a statement off of that as far as using a definition. I'm just told angles are congruent to each other. But I can always observe in my picture. So observe in your picture. I'm not going to switch screens right now. You already have the picture there. Observe in your picture and agree with me that we have angles that are supplementary because they form a linear pair. So I'm going to go ahead and use that to my advantage here, that I have angles that are supplementary and that therefore form a linear pair. And I'm trying to figure out how I can give myself a little bit more room here. So here's what I'm going to do. You just keep right on going. But I'm going to need to give myself some more room here. So I'm just going to bump that up. Things just aren't playing nicely with me at the moment in terms of my iPad. But I do know, okay, I do know that I'm going to need a little bit more room. I don't want to be cramped for space here. So let's move that way down. We can bring that up in a minute. And let's go ahead and extend this, give ourselves some room. There's my statement. There's my reason. And just to get my given information back here, we said that we had angle 1 is congruent to angle 2. Given information. And I'm proposing that we actually grab more given information from our picture, and that would be angle 1 and angle 2 are supplementary to each other. Definition of linear pair. If you went ahead and said that they add up to 180, you're one step ahead of me. LP is linear pair. I'm going to say that next, because now that I know that they're supplementary, I can use my definition of supplementary. So I've got this nice little setup here that if they're supplementary, then their measures have to equal 180, and that's what I'm about to state. Measure of angle 1 plus measure of angle 2 equals 180 degrees. I just saw that my sound cut out, that I accidentally hit the mute button, so I apologize. If you could bear with me, I'm not going to repeat the video, but I will catch you up with what I just said. You obviously saw the writing going in. I'm not sure when it cut out, but I went ahead and said, after my given information, that I know angle 1 and angle 2 are supplementary by definition of linear pair. If the angle 1 and angle 2 are supplementary, then I know that measure of angle 1 plus measure of angle 2 equals 180 by definition of supplementary angles. So at this point, I'm looking to see what I can do, and I want to get to measure of angle 1 equals 90 degrees. I know that that was my goal some time ago. So I'm going to keep that goal in mind. I want to get down here to measure of angle 1 equals 90 degrees. So I know that I need half of 180. And I know I also need to get rid of angle 2. It just so happens that I have this nice statement here that angle 1 and angle 2 are congruent to each other. So I'd like to make a substitution. I hope you're following here of my train of thought. I'd like to substitute out angle 2, and it appears that I could put angle 1 in place of it. So the only thing I need to do is I need to know that they're equal to each other, and I sort of do. I know they're congruent. I never said that they were equal to each other. So slight technicality here would be, let's go ahead and make a statement where we said that the measure of angle 1 is equal to the measure of angle 2. I'm going to make that step 4. And if you follow my reasoning here, I'm going to say, if I know that angle 1 is congruent to angle 2, skip over those statements, and then let's... Okay, I'm having major issues with things not recording right, so I'm trying to finish this video, and you might have to just finish on your own. I think I gave you enough of a setup there, but I'm hopefully going to not hit the wrong button here. Let's see, I don't know where I was, but I said that if angles are congruent to each other, then I know that their measures are equal to each other, and we are getting definition of congruent angles there. So if I didn't already say that, that's what we should have. That's a technicality, guys, and if you skip that step, it's not a super huge big deal, but here's what I need to do, and here's why I did that. I want to say that measure of angle 1 plus the measure of angle 1 equals 180 degrees. So I can now go ahead and replace angle 2 with angle 1. And that's my substitution property of equality. And like I said, some of you are already finishing this proof, so you probably already have on your paper, well, that's really the same as 2 times the measure of angle 1 equals 180 degrees by combining like terms. And I am totally agreeing with you. Let's go ahead and number our steps and see where we're at. I've got step 2, 3, step 4 here, step 5, step 6. Matching up with reasons 5 and 6, and let's see if we can connect or what we need to do. Can I go from knowing that 2 times the measure of angle 1 equals 180 degrees to saying the measure of angle 1 equals 90? Looks like I got rid of the 2 here, dividing there, and if I divide by 2, do I end up with 90? Indeed I do, so that ends up with being, we could call this step 7, and call my reason division property of equality. And then we set up the rest of it for ourselves, so we should be able to just follow this with step 8 is if the measure of angle 1 equals 90 degrees, then angle 1 is a right angle. Definition of right angle. If angle 1 is a right angle, then my lines are perpendicular. Definition of perpendicular lines. So it does kind of help sometimes when you work from the end because you know what you're headed for. Like I said, we wanted to get lines are perpendicular. So if we know what would tell us lines are perpendicular, we can work towards something, especially if we can get to an equation. And that was ultimately the equation that I was working towards. Notice I didn't need to know that both angles were 90 degrees. I only proved that angle 1 was a right angle because all I need to know is one angle is a right angle, and then I know I have perpendicular lines. Hopefully that helps. I apologize for the video quality because I had some issues with my iPad. So there's a recap of the proof, and if you didn't get that, it's the proof for theorem number 6. We're calling it the perpendicular adjacent angles converse theorem in the future because we just proved that theorem. We can go straight from here, knowing this, to saying this, and our reason would be perpendicular adjacent angles converse. Huge shortcut, because we would save ourselves 9 steps.